we connect it to the comparator Basically, what we are trying to do is give to forward and back the proper values comparing the variable current with the variable target. We also need to store the position of our stepper motor in order to do that. This is why we are putting this other kind of operator. Which is called arithmetic operator. We can put sum, subtraction, product, quotient, and modulo. Of course, they operate with arithmetic variables and produce arithmetic variables in choose complement. Their component level counterpart is the ALU. If we go forward, we need current to be incremented. If we are going backward, we need to decrement the value of current. This is why we are using the choice operators. For more information about these kinds of operators, we suggest to see the documentation of TaskScript technology. We save the design. So now we have modeled the manager, the steps. So what we need now is just to model the environment in order to try the behavior of our stepper motor. As usual, we need the initial step, which we'll call is_0. And we will model its data flow. For trying our stepper motor, we tried to give to the variable target 8 as value. In this way, once we launch the emulation, we should see our stepper motor to go forward as long as current is not 8. Now we model another step, which we call st_2. Actually, let's call is_1 the initial step, because we have called is_0 the initial step of task main. We write this transition condition, which means wait for 100 ms and then go to st_2. Now we model the step editor of the second step and we put 4. So now, during the emulation, stepper motor should go from 8 to 4. We select the board type. We validate the design. There are errors. Let's see. It's saying that there are 2 unallocated variables. This kind of report, as we can see, can be very useful. So we specify the physical location like the report was suggesting us. We revalidate it, and that's it. We have 0 errors. So actually we are ready to emulate already our design. We give a name to our emulation. We put 1000 cycles. And we give OK. Let's see if it works. Of course. Okay, we have a syntax error. Let's see to the compilation listing. Okay, let's go to main, to the environment. Of course, we forgot to specify the task that we needed to activate after the fork. Okay, now the emulation seems to look good. Let's select the variables we want to examine in order to check the behavior of our stepper motor. If I have done things right, we should see the current variable incrementing from the 0 position to the 8th position. Let's see. Actually, our oscilloscope looks good. We can see that our steps go from false to true in the correct way. Our current variable changes its value every 10 ms, just as we want it. It stays this way for 100 ms, actually for 30, and then it goes back to the 4th position. As we can see, the forward is true while the current position increments itself, and back is true when the current position goes from 8 to 4. So thanks to this oscilloscope, we have seen that our stepper motor behaves just as we wanted it to, and we are ready to upload it to the machine. Thank you very much for watching this video tutorial. Have a good day.